Good morning, everyone. So today, two more examples we'll discuss. That is hexagon pyramid resting on slant edge, one of his slant edge, and hexagonal pyramid resting on one of his triangular, slant triangular faces. And two examples of cone we'll discuss. That completes the entire the orthographic projections of the pyramids. Okay. Next week onwards, we'll start the prism. So same principle, same method we're going to use for this. Hexagonal pyramid of 25 millimeters side of base, 50 millimeter axis length, rests on HP and one of his slant edges. Draw the projection of the pyramid when the axis appears to be inclined at 45 degree to VP as given. So you know how to draw the hexagon with the help of the circle method, and he says it is resting on one of the slant edge. The slant edge, where you will going to get? The slant edge you will going to get the corner, correct? So that's why you take the corner condition for this. You draw the hexagon such that the corner should come right side on you. Draw as with the help of a circle, you can draw this regular hexagon. Then draw the diagonals by joining opposite corners. So you're going to get the center. So base point you call it as the O1 and apex point you call it as the O. So this completes your the top view. Now all the slant edges will look like a diagonals in this top view. Next, coming to the front view, you keep on draw the vertical projectors from this, like this, from all the 5 points, including the axis point. You draw it till it meets the XY line. Now from the axis, because in pyramid, the height always it is measured from the base center point to the vertex point. That is axis. So you extend this axis line and cut 50 millimeter on that. You call that as the vertex or the apex. Now you join this vertex or apex to the all the points or all the corners of your the base. So you're going to get a triangle. So this completes your the front view, and you're looking from the this side, that is front side. So A, B, C, D, you can see, you cannot see E and F. That's why E dash and F dash should be written within the bracket. So this completes your the initial position, front view and top view, or the two shape diagram. Next, second position. So he has told, so it is resting on one of his slant edge. So it has got six slants, right? The right side which I have taken the corner, that is A, and the corner which joins that corner to the apex, that is A dash O dash. So that is the slant edge, right side. Okay. What you should do is you should redraw this triangle such that the slant edge A dash O dash should rest or should lie on the XY line like this. How to do that? Take right side any one point, call that as the corner, that is A dash. Now you take slanted distance A dash O dash. A dash as the center, you cut XY line and call that as the O dash. How to get this the base point? Take A dash to D dash point, the distance. A dash as the center, you cut an R somewhere here. Okay. Similarly, O dash to D dash distance you take, from O dash you cut an R. Wherever these two are intersect, you call that as the D dash. Now you join A dash and D dash. After joining A dash and D dash, you take all these distances from here to here and from here to here and mark it here and transfer all the corresponding points without changing it. So you have to redraw. So the shape as well as size of this, including the points, everything of this front view, such that the slant edge should rest or lie on the XY line like this. So this completes your the front view. Now after this, you have to get the top view, you have to keep on draw the vertical projectors from all the points of the front view like this, and horizontal projectors from all the points of your the top view. Now coincide the points. So A is here, A dash is here, this is A dash. B is here, B dash is here, this is B dash. C dash is here, this is C. D dash is here, this is D. E dash is here, this is E. F dash is here, this is F. The base point O1 dash is here, this is O1. Apex point O dash is here, this is O. After getting all the points, first always we need to join all the base points. Since you are looking from the top, from here you are looking. The entire base of the pyramid you can see. That's why A, B, C, D, E, F. So all this, the corners, you join it with the visible edge. That is the entire base you can see. Now we'll see the slant edges, which are all the slant edges that we can see. You are looking from the top. So D2O, it is very nearer. You can see E2O and C2O also it is nearer to you. E2O and C2O, it becomes outermost boundary line. Whereas F2O, B2O, you cannot see. This way you represent it with the hidden edge. And A2O also you can see because it is resting on XY line. But the entire A2O I cannot represent it with the hidden edge. Already D2O, the visible edge is there. So that's why A2D I can represent the hidden edge. Okay. So and O to O1, the axis line also I cannot represent it because already the visible edge as well as hidden edge is there. But axis there, it is coincide with that the line. That's all. So this completes your the top view. Next, the next position, since he has clearly mentioned that the top view of the axis appears to be inclined at 45-degree line. So this information, so many times I have repeated this, top view of the axis is inclined. Our axis appears to be inclined. So these two sentences will give you the apparent inclination directly. No need to take the locus. Okay, that's why here the beta, that is apparent inclination, is given. Draw 45-degree line, any direction, either this direction or this direction on your XY line, right side. Then on that line you take the apex point, call that as the O. O to O1 distance you take, cut it here. So now the axes are fixed here. Now what you should do? You should redraw this apparent shape of the your hexagon pyramid such that this O1 should coincide on this 45-degree line O1. Like that you have to redraw it. So O1 I got it. Same the line O to D distance you take, cut it here, and O to A distance also you take and cut it here. 4 points will go to get. Remaining 4 points, how to get it? The box method or arc method, whichever the easy method you have, you can do it. So here D to this distance and A to this distance is same. You take those distances, from there you draw perpendicular line, which I have not shown here. You can draw perpendicular line. And that perpendicular line from this point to E, the same point to C, from here to F and from here to B, distances are same. You can cut on either side from these points. So you're going to get all other points without changing anything, including the visible edge and hidden edges. You need to redraw it. So after redrawing this, the last one is the front view. You have to draw the third position. So that you have to do it by drawing vertical projectors from all the points of your top view like this. Total 6 plus 2, 8 points will going to get, including the apex and base point. Here draw the horizontal projectors from the previous front view like this. Now coincide the points. A is here, A dash is here, this is A dash. B is here, it is B dash. B dash is here, this is B dash. C is here, C dash is here, this is C dash. D is here, D dash is here, this is D dash. E is here, E dash is here, this is E dash. F is here, F dash is here, this is F dash, the base point. O1 is here, O1 dash is here, this is O1 dash. Apex point O is here, O dash is here, this is O dash. So now also here in this case also, okay, so after identifying all the points, so you're looking from here. Here also the apex you are written towards the XY line towards VP. You are looking from here for the front view. The entire base you can see, which is your base A, B, C, D, E, F. You make it a visible edge. Now coming to the slant edges, you are looking from here. C to O you can see, C dash O dash. B to O, it can also be seen. That's why B2O is visible. Coming to the A2O, it is also visible. It becomes outermost boundary line. F2O you cannot see, make it hidden edge. E2O also you can see, make it hidden edge. And D2O also it is behind you, you cannot see, make it a hidden edge. And now at the end, axis line O1 to O, you join with the axis line representation. So this how, so you have to complete the orthographic projection of the hexagon pyramid, wherein it is resting on the slant, on of a slant edge. Okay. So similarly, similar to this, the last the possibility in this special case. So we'll discuss the hexagon pyramid resting on one of a slant triangular face. So what is the question is given? hexagonal pyramid, 25 millimeter base of side of base, and 50 millimeter axis length. Rests on HP and one of his slant triangular face. The triangular face where you will going to get, the triangular face you will going to get the base edge. That means for the resting on triangular face condition, you have to take the edge condition in the initial position of the true shape diagram. So that means, so you can draw the top view, the true shape diagram, such that any one of the edge should come right side of you. With the help of a circle, you can draw this hexagon. So you can name all the points and opposite corners you can join it. So you're going to get the center of the hexagon. You mark base point as well as the apex or the vertex point. This completes your top view. To get the front view, you need to draw the vertical projectors from all the points till it meets the XY line. And then which is the axis point here, this is the axis point. Extend this axis point vertically and then 50 millimeter you cut it on that. That is the height of your the pyramid. I call that as the O dash, that is apex point. Join it to all the points of the corners like this. You can join it to all the corners of the points. So it look like a triangle in the front view. Okay. So you're looking from here ABC, you can see the front view. D, E, F you cannot see. That's why D dash, E dash and F dash should be written within the bracket. So this completes your the initial position of the true shape diagram, both front view as well as the top view. Coming to the second position, he has given clearly that it is resting on one of his slant triangular face. So which is the slant triangular face? CD and O is the slant triangular face, because right side I have taken. So CD and O is the triangular face. That means C dash, D dash and O dash. This is the triangular face which has to be rest on the, it should be rest on the XY line, that is on the HP. What you should do, you take right side any one of the point, call that as the C dash and D dash point. You take this length, this is a triangular face, slant triangular face, the C dash to O dash, take it and cut it on the XY line and call that as the O dash. To get this particular point from C dash to this distance you take from this as the center, you cut an arc here. Similarly, from O dash, you take this distance to A dash, from O dash you can cut an arc. This intersection you call this as the A dash and F dash. Now you join it. After joining it, the base also will going to get the triangle you can get here also you can join it. Now take from this corner to the midpoint and transfer this point including the and join it from the midpoint till the apex. So what you have done, without changing anything, shape and the size of this front view, you have redrawn such that this slant triangular face resting on XY line. That's all. Like this you have to draw the front view. Okay. So after this, keep on draw the vertical projectors like this. After this, draw the horizontal projectors also from the previous top view. Coincide the points one by one. So that means A is here, A dash is here, this is A. B is here, B dash is here, this is B. C is here, C dash is here, this is C. D is here, D dash is here, this is D. E is here, E dash is here, this is E. F is here, F dash is here, this is F. Base point O1 is here, O1 dash is here, this is O1. Excuse me. Apex point O is here, O dash is here, this is O. Now, after identifying all the points, you are looking from the top side. The entire, by looking from here, the entire base of the pyramid you can see, which is the base. A, B, C, D, E, F, you make it a visible edge. And coming to the slant edges one by one, A to O and F to O, you can see since you are looking from here. So, A to O, F to O. And B to O, E to O also you can see, and it becomes outermost boundary line. What about the two slant edges which is resting on your XY line, C to O and D to O, that you cannot see. You make it the hidden edges. Axis line you can represent with the help of the axis line representation from O to O. This completes your the second position top view. Now coming to the third position, since he has given the axis is inclined at 45 degree to BP. That means this is the true inclination he has given. It is not the apparent inclination. We need to get the apparent inclination. How to do this? In many examples we have done this. So draw 45 degree line any direction, either in this direction or this direction. I'll take any one of the point on that. I'll take any one of the point at that. So I'll call that as the O. From this O, I'll take the true length. What is the true length of the axis? 50 millimeter. I'll take true length of the axis and cut it on 45-degree line. Wherever it cuts, just look at the cursor. On that point, you draw the locus line, horizontal line passing through that, the arc. Now you take the apparent length of the axis O2, O1, the previous top view, whatever you have. So the axis distance, that is the apparent length of the axis. You take this apparent length of the axis and with the same O as the center, you cut the horizontal line or the locus line which you have drawn and call this as the O1. Now you join this axis O2, O1. And if you want, you can extend this till it cuts the XY line. You measure that angle, whatever the angle you are getting, that is the angle of, that is the beta or the apparent inclination. Now after getting this O and O1, you have to redraw this, the apparent shape of the top view such that O2, O1 should rest it on this O2, O1. Like that, you have to redraw it. Okay. So after this, so how to get the other points? So O2, O1 I got it. O2, O I got, and then after that, so what you can do it from O1, you can draw a 90-degree line, perpendicular line like this. From O1 to E, O1 to B, you can cut it on either side. You will get E and B, or any the arc also you can get. Similarly, O1 to this point and O1 to this line, it is same. You cut it on the same the line, and then from that point you draw 90-degree line to that O to O1 line. After that, from here to D and C, from this point to F, and from this point to A, distance is same. You cut it on either side from here. So you'll get all the 6 points. So now without changing anything, you need to redraw it, including the hidden edges and the visible edges, axis line, everything. This completes your the top view. Okay. So after this, you keep on draw the vertical projectors from all the points like this one by one, and draw the horizontal projector from the previous front view. Coincide the points one by one. A is here, A dash is here, this is A dash. B is here, B dash is here, this is B dash. C is here, C dash is here, this is C dash. D is here, D dash is here, this is D dash. E is here, E dash is here, this is E dash. F is here, F dash is here, this is F dash. O1 is here, O1 dash is here, this is O1 dash. The base point, apex point, O is here, O dash is here, this is O dash. So here also the apex towards the XY line or VP we have written, so we have drawn. So that's why the base is here. So we are looking from here. So the complete, for the front view, the base you can see, that's why you make it the base, A dash, B dash, C dash, E dash, and F dash. Okay, it's visible. Now look at the slant edges. You are looking from here, B to O you can see, make it a visible edge. A2 also you can see, make it a visible edge, it becomes outermost boundary line. C2 also you can see, and D2 also you can see, it becomes outermost boundary line. Whereas E2O and F2O you cannot see, you are looking from here. E2O and F2O you cannot see. Join the axis at the end, O2, O1. So thus completes your the projection of the hexagon pyramid, where it is resting on one of its slant triangular face. Okay, so this completes all the special cases of the pyramid also. Either it may rest on one of its slant edge or one of its slant triangular face. So like that, the concept procedure remains same. So only thing is I have changed the pyramid from one example to other example. In this category, the two more examples that we're going to discuss today, a cone. So all of you know how the cone looks. Your eyes cone you can remember. So this is the cone. So it's a circular, I can say it has got circular base, and a cone doesn't contain any the edges or the corner of the base. It's a completely a circumference or the circle. Okay. So it may rest on any one of the point on the circumference of this the circle. Okay. And then so it doesn't contain any slant the edges of this are all called as the generator. It is called as the slant generator. The infinite number of generators are there which joins the base the base of your cone to the vertex or the apex of your cone. Okay, the axis of the cone starts from the vertex to the center of your the base of your cone, like this. This is regarding your the cone. Okay, so what is given in the question? Draw the projection of the cone of base diameter 45 millimeter and axis 50 millimeter long. So this diameter is 45 millimeter and axis height is 50 millimeter long. When it is resting on the ground on a point of its base side, that means it may rest on any one of the point on this the base. That's what he has given on HP. Ground is nothing but an HP. The axis making an angle of 30 degree with HP and its top view making an angle of 45 degree with the VP. The top view directly as given, that means this is the apparent inclination. We'll see to that. First, let say the cone, if you see from the top, it look like a circle. It look like a circle, and when you see from the front side of it, it look like a triangle. This is a triangle. That's what you draw a circle of radius 22.5 or the diameter 45 millimeter. You draw a circle like this, and also in circular lamina we have discussed this to divide the circle into some equal number of points. If you want to divide the circle angle is 360 degree. To divide the circle into two equal number of parts, you have to draw 180 degree. Okay, 360 by 2. The circle you want to divide it into 4 equal parts, divided by 4 means 90 degrees. So here I have divided the circle into 8 equal number of parts, that is 360 by 8, 45 degree. I have drawn the 45 degree line from the center, so I will going to get 8 points. Just for my reference I am dividing it. Okay, even if you want, you can divide it into 12 equal number of parts also. The more the number of points you take, more the smooth curve you are going to get your ellipse. That's all. So these lines, okay, as light as possible you have to show this. Okay, because in the cone we won't have any the slant edges over here, so that we can draw a visible edge like the only for our reference I have taken these points. Okay, don't make this the lines are the visible edges. It should be as light as possible. So I have divided the circle into 8 equal parts. I have named it. Find out the center of the circle. So you have, from wherever your the help of your compass, you have drawn the circle. That itself your center. The base center as the O1 and apex point of the cone as the O. So this completes your top view. To get the front view, draw the vertical projectors from all the points like this till it meets the XY line. So this is the center point or axis point. Extend it, and the axis height of your cone is 50 millimeter. So you take 50 millimeter cut, you call that as the O dash. Only the outermost boundary line. Okay, you have to make it thick. Okay, the rest of the lines you should make it as light as possible, because for my convenient the construction, the points these lines I have taken, this are all not the edges or the lines. Okay, should be as light as possible. Okay, cone, if you see from the top, it look like a circle, and when you see from the front, it look like a isosceles triangle. That's all. Okay, so this completes your front view. And he says, so it is resting any one of the point. So from the scale, from the top view, some name some points. So at the right side, whatever the point I am getting, okay, it's a. It is resting on point A, I can say. So he has given 60, how much? 30 degree with respect to HP. So here also same thing, the base and the axis are mutually perpendicular to each other. If the axis inclination is 30, what about the base inclination? 90 minus 30, it is 60. So right side you take any one point. From that point, you call that as the A dash point. You draw a 60 degree line. It is the base inclination. After drawing 60 degree line left side like this, so you have marked this as the A dash. So you have to redraw this isosceles triangle such that this base should rest on this 60 degree line. So A dash you have taken from A dash to E dash distance you take. With the help of your compass, cut it. You will going to get E dash. Join it. After joining it, similarly, this from A dash to this distance, and this distance you take it and mark it and transfer all the corresponding points also here one by one. So after this, So after getting this base, how to get this apex? A dash to O dash as well as C dash to O dash distance is same. From here you cut an arc, from here you cut an arc, you will going to get O dash. After getting O dash, this is the axis line or center line. Draw it and extend this line wherever it meets the XY line. You measure it. So definitely, so the axis inclination, because base inclination 60 degree I have taken, it has to be 30 degree. And this is a light line, so don't make it a thick line. So this completes your the front view. Now to get the top view, you have to keep on draw the vertical projector from the front view and horizontal projector from the top view like this. You keep on draw the vertical projector from all the points like this, and draw the horizontal projectors from all the points of your the top view. Coincide the points. First, A is here, A dash is here, this is A. B is here, B dash is here, this is B. C is here, C dash is here, this is C. D is here, D dash is here, this is D. E is here, E dash is here, this is E. F is here, F dash is here, this is F. G is here, G dash is here, this is G. H is here, H dash is here, this is H. The base center point O1 is here, O1 dash is here, this is O1. Apex point O is here, O dash is here, this is your O. Okay, so after getting all the points and the cone is tilted like this, and you see from the top, this is look like an ellipse. Okay, in the circle also, when the circle is tilted in the circular line we have seen, it look like a ellipse. And here this half of the ellipse you can see in the top view, this the remaining half of this you cannot see. So that is what you have to represent. Join all these points with the help of a smooth curve so that it should look like a perfect ellipse. Since you are looking from here, this the first half of your the ellipse you can see, that is E dash, F dash, G dash, D and C. You can see this particular portion of the half of your the ellipse you cannot see. You make it hidden edge further. And at the end, no need to join any edge or line here. What you have to do? You need to draw a tangent to your this ellipse to the vertex or the apex point like this. Okay, so this how, okay, you have to draw the top view. Only this, the base half of these your cone you cannot see. That's what the half of the ellipse you have to represent with the help of the hidden edge. That's all. Now coming to the third position, he himself he has given the apparent inclination. The top view of the axis is inclined at 45 degree. You take 45 degree any direction, either this direction or this direction which I have drawn, and on that line you take any one point, call it as the O point. Take this O to O1 distance, this is the center, you cut it here, O to O1 you get. Similarly, O to A distance you can take on the same point, you can cut it. O to E point also you can take the same line you are going to get. So box method you can go for to get the other point. From O1 you draw a 90 degree line and take this O1 to C, O1 to G distance, cut it on either side, you are going to get G and C. Similarly, O1 to this distance you take, draw perpendicular line. O1 to this distance you take, draw perpendicular line. On that line from here to D, from here to F, from here to B, and from here to H, the distance is same. You cut those the points at 90 degree line, you will get all the points. Now also without changing its shape and size, so this half should be, the ellipse should be visible edge. This half it is hidden edge, including the tangent, everything you transfer it without changing anything. This completes your the top view. Coming to the last front view, you keep on draw the vertical projectors from all the points like this. 8 plus to 10 points will get, and draw the horizontal projector from the previous front view like this. Okay, coincide the points one by one. A is here, A dash is here, this is A dash. B is here, B dash is here, this is B dash. C is here, C dash is here, this is C dash. D is here, D dash is here, this is D dash. E is here, E dash is here, this is E dash. F is here, F dash is here, this is F dash. G is here, G dash is here, this is G dash. H is here, H dash is here, this is H dash. Base point O1 is here, O1 dash is here, this is O1 dash, apex point O is here and O dash is here, this is O dash. Now here also the apex of the cone is towards XY line or VP. The entire base is towards, you are looking from here for the front to the entire base of the cone you can see. See, initial position you have written, second position you have tilted, third position you have tilted like this. The complete base of the cone you can see. So that's why A, B, C, D, E, F, G, H. So you have to join this with a smooth curve. First you draw a light smooth curve. Afterwards you can make it the thick line. So after that, so for this the arc or the curve, you can draw a tangent to the apex like this from any point. And axis line you can show it like this. So this completes the orthographic projection of the cone, okay, which is given in this the particular exercise. Okay, this is one kind of the exercise. So one more example we'll discuss wherein the cone is resting on one of a slant generator. Okay, the last one we're going to discuss a cone of 50 millimeter base diameter and 50 millimeter axis length rests on HP with one of his generator. That's what I told. A generator is nothing but it's a line with joins. It's an infinite number of generators you're going to get from the base of your the cone to the vertex. Okay, it has got n number of generators. It is called as the slant generator. Generator draw its position when the axis is inclined to VP at 30 degree. So axis is inclined, he has given. This is the true inclination itself he has given. We'll see at the end. Here also, as usual, you draw the top view, the circle. So 50 millimeter diameter. That means 25 millimeter radius you can take and draw the circle. Divide the circle into 8 equal number of points. Name it. And these lines should be as thin as possible. Just this are all construction line to get the center. That's all. After completion of this top view, draw the vertical projectors from all the points like this till it meets the XY line. Extend this axis line, and then on this vertical line you cut 60 millimeter. That is the axis height. Call that as the O dash. Only the outermost boundary line you make it thick. These lines should be as thin as possible. Okay. So you are looking from here A, B, C, D, E. You can see. You cannot see F, G, H. That's why F dash, G dash, and the H dash should be written within the bracket. This completes your the front view and top view. That is true shape diagram. Second position. So he has given it resting on one of his generator. As I told, it has got infinite number of generator. For my construction work, I have divided it into 8 equal parts. The point that connects the base to the vertex or apex, in my case it is A dash to O dash. I'll consider this A dash O dash as my this slant generator. So I should tilt such that okay, the A dash and O dash, which is nothing but a slant generator, should rest on the HP, in the sense should lie on the XY line. So I'll take any one of the point right side of the XY line, call that as the A dash. Now I'll take the slant generator, that is A dash O dash distance. From A dash I'll cut this XY line. So I'll get O dash. How to get this A dash point, E dash point? From A dash to E dash you take the length. From A dash you cut an arc here. Similarly, O dash to E dash you take the distance. From O dash you cut an arc. Wherever these two arcs intersect, you call that as the E dash. Now you join E dash and A dash as well as E dash, O dash. Now after joining this line, you take these corresponding the distances and mark it here and transfer all the corresponding points here without changing it, including the axis line, everything you transfer it. So this completes your the second position, front view. Now to get the top view, keep on draw the vertical projector from all the points of your front view like this, and draw the horizontal projectors from the top view like this. Coincide the points here also. So here, A is here, A dash is here, this is A. B is here, B dash is here, this is B. C is here, C dash is here, this is C. D is here, D dash is here, this is D. E is here, E dash is here, this is E. F is here, F dash is here, this is F. G is here, G dash is here, this is G. H is here, H dash is here, this is H. and base point O1 is here and O1 dash is here. This is O1. Apex point O is here. O dash is here. This is your O. Okay. So after getting all the points here, also you are looking from here. Okay, the complete base you can see it look like a ellipse here also. See the second position you have rested it like this. You have kept it on by looking from the top. The complete this base it look like an ellipse. So that's why. So you draw a ellipse by joining all these points with the help of a smooth curve. It look like a ellipse. The complete the ellipse you can see at the end. You join this vertex to this ellipse with a like a tangent, or you join this major axis point to your the vertex or apex. Show the axis line representation. That's all. So this completes your the top view. Coming to the last the position, since he has given uh, the true inclination itself, so that's why how much he has given, 45 degree he has given. So any direction, either this direction or this direction, take 45-degree line, and that you take the point O, you can take apex point. From there you take the true length of the your axis. From there you cut that 45-degree line. Wherever it cuts, you draw the horizontal line. That is nothing but your locus line you are drawing. And this locus line, what you have to do is, you take the apparent length of the your axis in the previous top view. O dash to O1 you take with the same O as the center. You cut this locus line here. Now you call it as the O1 and join this O to O1 and extend that line till it meets the XY line. That is your beta or the apparent inclination. After getting O and O1, you have to redraw this cone such that the apparent shape of the cone, this O1 should coincide with this O1 like that. So O1 you got. Similarly, same line, O to U distance you can take, you can cut it here, that is E. O to A distance also you can take, you can cut it here. So these points will go to get. How to get the other points? O1 to this distance you can take, O1 to this distance. Draw perpendicular line. And from O1 also you can draw a perpendicular line. On those line you take these distance and cut it here. And from O1 to G, O1 to C distance is same. You can cut it here. After getting all the points, once again you draw a smooth curve so that it is seen as the ellipse and completed without changing it, and including this the joining to your vertex, everything you completed. This completes your top view. Coming to the front view, you have to keep on draw the vertical projector from all the points like this. Total 10 points you will get, and draw the horizontal projectors also from here. Coincide the points A dash, this is A dash, B dash, this is B dash, C dash, this is C dash, D dash, this is D dash, E, this is E dash, E dash, F dash, G dash, H dash, base point O1 dash, apex point O dash, this is O dash. Now you are looking from here, the front view, the entire base you can see here also. The apex is towards the XY line or VP, the base is towards you can see the entire base. Join these all these base points with a smooth curve. You won't get exact ellipse over here. So some irregular shape of the curve you're going to get. You join it with the help of a smooth curve. At the end, you draw a tangent to that the curve. That's all. And axis line you represented. This how you can complete the projection of the cone in this particular case. Okay, so this completes your all the examples we have discussed. Okay, so